Okay. See if I can get this thing to go up. There we go. Up, I say. All right, I think it's going to go up. So, all right, so we'll talk about access control. So you have to have some part of your system that decides whether users are allowed to do things. And what you typically want is centralized access control. This is why people need domain controllers. The reason you need a domain controller is you have one central point of administration. So if you want to add a user, you add them in one place, and now they can log in any machine they want. And more importantly, if you want to remove a user, you can delete their account from one place, and you know that they cannot log in anywhere. Whereas if you're using local accounts, you have to update the user base on every machine, and there's probably one machine that's in use or broken or something. And so there are people that should no longer be allowed in that have a way in. So one centralized point for administration is a huge selling point. And another thing you might want is single sign-on. This means where you only have to log in once, and your authentication is migrated to other machines, and you're allowed to access other machines without having to log in again. Of course, that is a problem. Yep. It's the opposite of, say, defense in depth. Anyway, so this is AAA services from the old telephone network: authentication, authorization, and accounting all in one place. So decentralized access control is the other system where each location has their own independent database. And this, of course, gives them more power over the data, but it means that you don't know that your security policies are actually being enforced everywhere. And the most extreme version is discretionary access control. But that's even more crazy, where the individual users have discretion to use their own data. A single sign-on is enormously desirable, and everybody is going for it. You know, everybody says sign in with Google or sign in with Facebook, even for other services. So that is very convenient, but it means that if someone gets your Facebook password, you've lost all that stuff. Of course, you know, it means that Facebook, you turn on two-factor authentication, which Facebook has, although not by default, and everyone supports it, which I'm not sure they do, then you could have a strong authentication everywhere. But if I was running some kind of game or something, I would just let people sign on with Facebook, because I don't want to take the responsibility of somehow storing their passwords and making them available. I'd rather just outsource that responsibility to Facebook. Anyway, that's the game. So session management of single sign-on, it's recommended you better have strong authentication so you really know who somebody is if you're going to let them sign into multiple systems all at once. But attackers might hijack an authenticated session. This is a common technique. Once you let the user log in, and then you take over the session in progress, then you don't need their password. Anyway, session timeouts help. Yeah.
School district, we have a single sign-on. I would sign on to the Outlook email,
Mm-hmm.
and then try to sign on. So,
you have an LMS, and we also have it's also tied into a Google.
Oh yeah.
So they would hijack one of those applications.
No, suppose I'm able. Suppose in the simplest case, suppose you're not using HTTPS everywhere. Like something many people did before is they would use unencrypted protocols on their LAN and only use encrypted protocols on the WAN. So suppose you were using HTTP on campus to log into the campus server, and then you are in all these systems. I could hijack the network traffic and insert my commands in there, and they would execute as if they were you. That's one way. Now, the earliest version of this, they would actually intercept a TCP session with something like FTP. The users log in with FTP, and then I would just send packets with sequence numbers that would replace your packets on the wire. That's one way. One very common technique now is cookie theft. If I can steal the cookie, because once you log in, it gives you a cookie, and then it just sends that cookie with a request. So if I can steal the cookie, for example, by stealing your phone, then I'm in. I did a project 4 years ago on this where I tested how many sites have cookie reuse. And it turned out that Microsoft Office 365 and about half the web services I tested had the following entertaining property. If I steal your cookie and come in next week to log in, after you have logged out, it will still let me in with your cookie. I don't know your password. And even if you change your password and log out, I can still get in with the old cookie. They never invalidate cookies on the server. And And until about 5 years ago, many services would log in over HTTPS and then go back to HTTP and send a cookie over plain text. So it was actually quite easy to steal a cookie. And stealing a cookie is more powerful than stealing a password. You can't, the only thing you can do is delete your account to stop that cookie coming in. And when you log out, logically that cookie should stop being valid, but more than half the web services I tested did not do that. So that's the modern version of session hijacking. I never got your password and I never logged in as you. It is interpreting my traffic as a continuation of your previously established session.
So at Mansat, if you want to get into the financial portion, so you're running a grant or their banner, if you've heard of Banner 9, you cannot log with your password from your house or anywhere else. You have to be physically on campus.
And that is two-factor authentication. It's something you know and your location.
And I was lucky enough, I live close by, but think of you're a grant president, you have to get this thing done by Monday and something's been slow. You have to physically try to happen. But you know what? I appreciated it because it literally we get 100,000 attacks a day.
Yeah.
So,
well, you know, usually there is some way to bypass it. And that's why one security pen tester technique I've heard talked about is the best way to defeat this is to just be relentlessly stupid. Call the help desk and say, it's not letting me in. I can't get in. I forgot my password. I typed in the number on my token and it wouldn't take it. I'm trying again. I'm trying again. Oh, this is so hard. And they will get so fed up with you, they will just bypass it for you if you're relentlessly stupid and incompetent until they get frustrated with you. Anyway.
our help desk is our students.
Yeah.
And they will not, they say, we'll call you back. Give me a number.
Yeah. Yeah.
Which is really good.
That's
and
really
then,
good.
Then they go and actually call up somebody higher up and said, you're not the one, right?
Yep.
Or whatever. So it's actually very good.
This actually,
put in a lot of the So we get a lot of grants because I brought in 7 of it myself.
well, this was actually improved greatly in America by DEF CON. About 5 years ago, DEF CON had the first social engineering contest, and they would put people in a booth, and they were supposed to call a company and talk them into doing something stupid. Like they would tell you what browser they were using, and then they would go to the URL you give them, which means you could own them. And they called like 150 major corporations, and they got in like 145 of them. And this hit the press and Department of Homeland Security, and everybody freaked out. And by the way, the only 5 companies they couldn't get into are when women answered the phone. Women are much more resistant to this attack than men. And I hope I don't get punished for being sexist, because this makes sense to me, because I remember when I grew up, this is how the human mating ritual works. The man goes out with the woman, and the man brags about how great he is, trying to impress her, and she sits there nodding and thinking, this guy is an idiot. And men will brag about everything, and the women are saying, this is all garbage. They're deciding how much of it is lies, which it mostly is. And the men are sailing along oblivious, thinking, oh, she's eating it up, she loves me now. That's so.
It's oldest. Women make the best social engineers.
Yeah, yeah.
Because
they've learned from an early age to carefully filter what comes in because it's probably a lie.
And it's the oldest profession that the women had. So in the DC, India, I know, and the Jishus, they were sent to kill people or assassinate, and we were the best social engineers for that.
Yeah.
It's in our DNA.
Yeah, well, anyway, this is why I really think it's wrong that so many of our security people are men and not women. I think we really need at least half women protecting us, because they're resistant to attacks that men are very vulnerable to. Anyway, so you have a provisioning of your passwords and other credentials. So there has to be a life cycle. You have to notify people when they expire, tell them when, determine when you turn off inactive accounts, when have some proper offboarding process, so when somebody leaves or is fired, you actually deactivate their account. There's a whole lot of famous breaches where they fired the administrator, but they didn't cancel their credentials, so they went off and then nuked all the servers and everything using their old credentials.
So if you were the network administrator,
yeah,
then who walks you out? I'm sorry, I'm asking this.
This was my job at the escrow agency. I was a de facto network administrator, and whenever they fired somebody, they would walk them to the back room, and while they're going there, they would call me, and I would cancel their account. So before they know they're fired, they're already locked out. Then they escort them to their desk, put their stuff in a box, and shove them out the door.
Yeah.
And if you're hiring the administrator, then you're going to have some other administrator. And this is what happened to San Francisco. San Francisco network administrator turned rogue and betrayed his own boss and locked everybody out of the network. And they had prepared for this. They thought there were supposed to be 3 network administrators, but this guy had 4 felonies for armed robbery, which he had concealed, and he was a scary guy. So he had intimidated the other 2 network administrators into just letting him do everything and lock them out and don't tell anybody. So they thought they had other administrators that could lock him out, but the other guys couldn't do anything, and they didn't know that because he had like terrified them. So he was the only guy that had the passwords, and he wouldn't give them out. It was the whole city was locked out of its own stuff for a while.
He was locked in jail for a long time, so he gave him up.
He got a 4-year sentence. He was in jail for like 30 or 60 days before he gave the mayor the password, and then he got a 4-year sentence. Yeah.
There was a network administrator for a city in Canada, and he hijacked the whole city, and there was sewage running for 5 days before they actually changed it.
This is why there should never be any one person that is alone in a position of power in your network. There should always be somebody else. And they knew that, and they thought they had achieved that. They didn't know it wasn't true. But no one person should be the single, trusted, all-powerful thing at your company. That's a single point of failure. Anyway, access to aggregation is a problem where you gradually accumulate more and more permissions. This happens at my college. Every time you have a new classroom, they give you another key. They never take them back. So if you want to get in the room, you just look for the oldest teacher because they have a drawer all full of keys. The older you are, the more keys you have. And you're not supposed to do that, of course. And then there's authorization creep where you get more and more permissions, but you don't take away the old ones.
Have you tried to give all your keys back?
Oh, no. When I was a young teacher, I might have tried that. Now I have lost all respect for the system, so I do not attempt to even humiliate them or argue with them. I just accept all their stupidity now. Yeah.
So I've been at 20 years. Last year, I was so tired. I gave them all the keys, and she goes, "Why do you want to do that?"
That's right. Of course.
I was like,
Oh, I know nothing good will come of that.
I could get into half of Mount SAP, which is on a 200 acres. That's a lot of buildings.
Yeah.
Somebody, you know.
This is very much like white hatting, like telling someone about a vulnerability when they don't have a bug bounty. It's kind of an exercise in self-abuse. The only reason I do it is because I use them for homework. So, but normally there's trying to tell people about security problems when they don't want to hear it is just an exercise in beating your head against the wall. Anyway, federated identity management is a big thing Microsoft pushes, FIM servers. This way you can log into one company and they put a FIM server on another company so your authentication can be accepted over there. This is actually quite useful for business purposes. Microsoft talked about how they did this with ADP. ADP in Texas prints everybody's checks. For some reason, they're the best solution for payroll checks and taxes, so everybody uses them. So at Microsoft, they implemented a system where the original system, everybody had to have a Microsoft account to do their work, and then they had to make an ADP account to print out their W-2 form. And they gave ADP a FIM server, so it's Federated Identity Management, so your Microsoft authentication would be accepted at ADP to print out your W-2, and everything is great, but then Microsoft had a round of layoffs. So they laid off like thousands of employees, and they could no longer log into the domain controller, and they couldn't get their W-2s. So that's the downside of this. But anyway, and like I say, in practice, Facebook seems to be the world's identity provider. Everywhere you go, there's an option to log in with Facebook. So they are the trusted source of identity for the whole internet, more or less, which is what Obama said the government should do. That didn't fly either. In practice, consumers have chosen Facebook, which is why all the privacy advocates say I have to hide from the NSA, but I'll give Facebook everything. I just have a problem with the threat modeling here. I think they haven't really thought this through. Facebook is going to screw you. And the odds are very good that the government is not going to screw you. I'm sorry. I don't agree with your estimate of the threat model here. Anyway, so that's right. Here's what Obama wouldn't have internet ID for Americans. That was 2011. He said, people are having to remember too many passwords. We'll just have to remember one US government password, and that'll be the gateway to everything. This will be great. And next day, he had some meeting with his advisors, and he said, let's just pretend we never said that. So SAMLOL is fun. This is used to send security data over networks, security assertion markup language. This is used by many providers to send information up. Identity as a service is called cloud identity. Many people have tried to do this, just have an identity service on the web somehow that you use. Microsoft tried to do this with Live ID. Obama wanted to do it. It turns out Facebook seems to have won this battle without trying. By letting other people use their authentication, it's become quite popular. So credential management systems are necessary now that we have dozens of accounts everywhere, dozens of passwords. I think I saw statistics that like people at the level of like a system administrator have to memorize like 37 passwords on average now or something like that. That's the kind of thing that made Obama do this. He just thought, you know, this is crazy and I'll help people. But anyway, so you should have password managers that can give you some secure place to store your passwords and make sure you have a different password everywhere, and you only have to remember one master password now.
Quick question.
Yeah.
Identity as a service.
Yeah.
Do they have any guidelines like PCI or no?
Oh, no. As far as I know, there's nothing resembling, because it never became a popular thing. So there never was any industry self-regulation or rules. It's just a possible function. And various people have offered it, like Microsoft, Google now does, and Facebook does. But I don't think anybody has gotten so far as like making rules or best practices or anything. It hasn't turned, I've never seen them. That's true of most things that are fairly new and not that popular. You only make rules when something becomes some kind of standard activity, and I don't think this is that standard. Anyway, so if you want to integrate third-party identity services, you could host a copy of it locally, or you could allow internal applications to integrate with a cloud identity. That's what people do. Facebook has an API for this. You can make a call to the API and say, go ask Facebook if who this guy is, and Facebook will answer saying, this guy is this name, and do it. So maybe it's worth demonstrating this one here. I have a project about this one, and it might make it more clear. It's SAMLOL. SAMLOL, okay, samlol.samsclass.info. Okay, so this is my SAMLOL project, and I think this might be worth doing. So you have to run it through burp to have good fun with it. So burp is the proxy that hackers use all the time. Developers use the Charles proxy. Microsoft people use Fiddler. They all do the same thing. A proxy is a local piece of software that listens on a local port. Mine's listening on 127.0.0.1.80.80. And if I tell my browser to go through that, then it will intercept and let me see all the traffic. So I go into Preferences, Proxy, and I tell it to use 127.0.0.1 for HTTP. Okay. And I made this so it's using HTTP instead of HTTPS to make life easier. So now if I refresh that page, if I go here to HTTP history, I can see the request that did that. So I've gone to the service provider. Now this is what happens. I might have something like a game made by a small company. It's not very savvy. And they have some service they offer, like a game, but they don't want to handle identity. They want that to go to an identity provider, which is going to be some big, powerful company like Google or Facebook that probably knows what they're doing. So here I am unlogged in. So it says you are not logged in. If you want to log in, you can log in as user1 password or user2 password just so we can see it. So let's do a login and see what happens. When I log in, it goes to a different place, the identity provider, which would be like Facebook. And this is a different system. So here I put in my user1 and PWD and log in. And now I'm back and I am logged in as user1. And I haven't won the game yet because I'm not logged in as admin. The goal of the game is to log in as admin, even though you only have accounts user1 and user2. So here's the process whereby this happens. First, you send a request to the service provider, and then you tell it you want to log in. It sends you over to the identity provider. The identity provider takes your credentials, and it replies with a SAML record. And that is going to come down here someplace, maybe down here. Let's see. Might take me a couple tries to find it. Someplace I'm going to see a whole block of SAML. Let's try using SAML Rater, which is here. There we are. All right. Just a moment. I might have to read the instructions for this project to get it right. I'm not finding what I expected to find out. Oh, headers, response raw. I'm supposed to see there a whole blob of, that's not it. Okay, I send a request. Let's follow it logically. Here I am sending my name and password, and I'm not seeing my name and password. Where is my name and password? Okay. SAML request. Here's the SAML request. What was that about user pass?
Number 5.
Oh, login user pass, probably good. So here's the SAML request, good. Here's the response. Okay, this is probably at user pass. This is the request. And login user pass, auth state. This is going to the identity provider. And here's the response. Okay, here's another request. Oh, this post down here. That's probably where the username and password would. Yeah, okay, this is where I sent my username and password to the identity provider. I sent it up there. Now the identity provider responds to that with, there it is, the SAML data. Thank you. This is the SAML response. It is this long blob of horrible junk. This is like the DNS sec record, the RRSig. This long blob of junk is a SAML statement. Now you can decode it with Python or any other. It's just base 64. It's not encrypted, but there's a burp extension called SAML Rater that will decode it for you. So if I go to SAML Rater, I can see it if I can only figure out how to do it. And so let me intercept one and play with it. I'm going to get my instructions for this one because I'm getting a little clumsy. SAML LOL instructions. Oh, I think it's actually from this page. Let's log out. And yeah, here's the explanation and instructions. Okay, good. That's it. This is the homework I give my students. So let me follow my homework so I'm not as clumsy. So here's how you understand PAML. This is the process we just talked about. You start at the service provider. It sends you to the identity provider where you get a certificate, and then you send that back to the service provider, so it never sees your password. It gets a SAML statement from the identity provider, which says, I know who you are, and now it knows who you are. So you put on SAML Rater, and now you can view it with SAML Rater. So proxy HTTP history, find the purple items, and click one of them, and I'll see a SAML Rater tab in the history list. Okay, so the purple items should now have a SAML Rater tab somewhere. Certificates? That's not what it is. I can't find it. That's why I'm losing my mind. Where's the SAML Rater tab?
Let's see it on one of the clicks before.
For some reason, I'm not seeing it. Oh, maybe it's down here somewhere. No?
I think you have to click on the HTML first at the bottom. No,
HTML?
no, go to response.
No, yeah, but anyway, let's see. Here, I should see it there. So if I go to SP Post, there should be a SAML Rater tab here.
Let's see it.
This one.
Yeah.
And it's totally not there. I think something's wrong with my SAML Rater extender here. I'm just going to show you the picture then. I don't know what's going on here, but I don't want to hold up the whole class for that. So anyway, this is the assertion. And the point is, this is a real SAML library I put here. There are 15 common software packages used for this purpose, and about 12 of them had this flaw. They didn't actually validate those certificates, or they made other incredibly stupid flaws. So in this case, all you have to do is remove the signatures, and it will believe anything you say to it. And this is common because what happens is, even if the service provider is working correctly, if the identification provider is working correctly, like through Google or something, it then sends a certificate back to the client. And the client is supposed to do all this work to verify it, and they often just don't bother. They just take what it says and believe it. So I can modify it to say I'm the administrator, and they will just accept that because it's too much bother to believe it. Just like Android apps don't bother to verify the HTTPS certificates. So the game company can misuse the API and believe anything they hear from the identity provider, and there's no way the identity provider knows that happened. Anyway, that, and a lot of them made these flaws. Anyway, that's as far as I want to go on that. Yeah.
Go down, I think you'll get it.
Yeah, I never saw it anywhere. I don't know what's happening here, but there's something wrong, and I can't figure it out right now. I think I have to remove and reinstall the extension in burp or something. More likely, I'm just making a simple, stupid mistake. Anyway, that's our third-party identity services. Then there's LDAP. This is what domain controllers use. It's sending data through a local area network to get up there. It can use authenticated or encrypted or unencrypted traffic. But it's in Microsoft domain controllers, it uses Kerberos authentication. Kerberos was the improvement of the challenge response process to try to prevent sending plain text passwords over the wire. This uses encryption and authentication to scramble passwords on the wire with a lot of things: a principle of realm, a ticket, credentials, key distribution center, a ticket granting ticket, and a golden ticket. And the primary hacking tool for this thing is Mimikatz. Mimikatz is made by a Belgian or French or New Zealand researcher, and his guy is hilarious. Every time Microsoft, he can hack into Windows domains better than anybody. He can steal the golden ticket from out of the network traffic from your domain controller. And the golden ticket is created when you first promote the machine to a domain controller, and it remains valid for 25 years and never changes. And he can crack in everything like that. And he steals it and he publishes it in open source code, and Microsoft updates their stuff, and always within 2 days, he updates his thing to hack through it again. Microsoft can't stop him. He's pretty hilarious. And Mimikatz is a hilarious hacking tool, and he totally hacks this system. He steals the Kerberos key and the tickets off the wire. Anyway, so you got a key distribution center, you got a session key and a secret key flying around, and you get a ticket from the ticket granting service. So instead of sending your password over the wire, you request a ticket, and you get a ticket that gives you 10 hours of authentication to access something, and it's only good for that time period. And then you have to get a fresh ticket. That's how the system works. And there are various defects, but this is an MIT-based system, and the stuff that's sent over the wire is related to your password, and there are hacking tools that will try to extract your password from it, but it's pretty difficult to extract your password from it. And Mimikatz works differently by hunting through the memory of systems and finding things it can steal, which can deduce the ticket from. They find places that it's hidden. So there's this complicated multi-stage process talking to various different servers, sending stuff over the wire, none of which is directly your password, but often parts of this are related to your password. And so it's considered pretty strong, but there are various ways to hack it. So you have either way, one thing about Kerberos is all your devices have to have accurate clocks. If they don't all agree about the time, then this time-based authentication will fail. This is why Microsoft always wants you to put network time protocol on every device. Network time protocol itself is a hilarious security disaster. Network time protocol was used as a, I saw H.D. Moore, the inventor of Metasploit, demonstrate this at B-Sides about 5 years ago. Network time protocol had been not updated in like 15 years. It's a UDP-based service, and it turned out that you could send a request to the NTP server to dump the cache, which would show you the last 600 servers that had got the time off it. For some reason, that was stored on the server and open to everyone by default. So you could map private internal networks at every corporation in the world by just harvesting their NTP responses. And everybody used the same NTP cluster. See, there were a few companies like University of Maryland, a few public put up NTP servers, and everybody started using them. And then somebody distributed something like, I think, an Internet of Things device with a hard-coded IP address for the University of Maryland NTP server, and they flooded it with requests, and it went down. So they replaced it with a round-robin cluster of servers. So there's a bunch of servers, and you don't know which one you're talking to, and every server on the internet will synchronize like every 5 minutes or hour with this. So it has in the cache the internal map of every network in the world. He harvested the whole thing from Amazon Web Services. Well, what's even worse is that request that gets the whole cache is only like 50 bytes, and the response is like many kilobytes. So it's a huge DDoS attack. And people have been using NTP servers to multiply. With an NTP server, you can multiply your bandwidth by 100. And this I was warning companies and colleges that had this weakness, but I decided to not bother warning them because once they start doing this, that is so powerful, it freezes your entire college network. So you notice when people start exploiting this. And so even though I didn't really have to tell them, the people, pretty soon they would find out anyway. But anyway, so Kerberos has a lot of weaknesses. If you compromise the key distribution center, you get them all. And there are replay attacks possible. And there are various other weaknesses. But still, it's considered pretty strong. But it's been around for a long time. Anything that's been around for a long time will have some holes that have been patched. SESAME is a European version that is similar. Radius is the original thing. The acronym has dial-in user service. It comes from the days of 56K dial-up. And Diameter is the more modern, more secure update to it. TACACS is Cisco's proprietary system to do the same thing, to store credentials at a central server. And TACACS Plus is the newer version that encrypts everything and gives you two-factor authentication and so on. PAP was the original system that sent plain text passwords. CHAP was the first one to avoid it by sending you a challenge, which you would hash together with your password and send that over the wire. Microsoft Active Directory domains use Kerberos, and they have domains, and you can have trust relationships between domain controllers, one-way or two-way transitive trusts, where authenticating here gives you some privileges there, or vice versa. And that is really important if you have a company that, say, acquires another company or establishes a business partnership with another company, where to some extent, logging in here should give you some privileges over some portion of this network. And Microsoft is the only company that really provides good tools to properly control that. That's why Microsoft domain controllers rule the world. Every big company has to use them because they have what you need to manage the problems that come when you have a really big network of computers and real business relationships with other big networks of computers. And other servers like Unix servers have got nothing to compare with this system. So there's three basic models of access control: discretionary, mandatory, and then there's something they call non-discretionary. Discretionary is what you have in a home environment. You own something, you can do whatever you want with it. It is your discretion. The owner can do anything they want with the objects they own. And everything on a PC has an owner. Every file has an owner, every folder has an owner, every printer, everything has an owner, and the owner has the right to do whatever they want with it, share it with anybody else. Yeah.
Role-based would go under discretionary.
No, role-based is what Active Directory domains, where you are sorted into a role and you get the permissions that the administrator gave your role and you can't change them. So that's not discretionary. That's role-based.
So where it wouldn't fall into any of these three models?
No, it's a separate one. Yeah. That's why mandatory access control is the strictest, where you have everything has to go to a top administrator and get classification, and it's burdensome and expensive. Role-based is in between. So the here's the one, the non-discretionary one. There's two of them: role-based and task-based, where you sort users into groups, and the administrator is the one that can move them from one group to another, and they only get the permissions assigned to their group. And if they want more permissions, they have to go to the administrator. This is the one that's reasonable for companies. All right. So here's role-based access control, where you sort people into groups like basic user, auditor, and engineer, and you give them different permissions, and users are put in groups. Task-based is where you focus on the task instead, which is just essentially the same thing. Then there's something called rule-based access control, which is just a more general logical thing like firewall rules, where you have some kind of statements if-then that determine your permissions. These would be things like network time restrictions, where you can only log in up to 5 p.m. and not after that. That's a rule-based access control. Okay, and then you've got content and context dependence. They might look at what you're doing and decide whether to allow it. For example, a spam filter. You can send email unless that email contains certain words, in which case it will be rejected. So the content of the request determines whether it's approved. And you can have context-dependent access controls. Like I mentioned, your credit card might work if you're at the same physical location as the origin of the transaction, but not otherwise. So that's context. All right. And we've got another Kahoot here. And this is 6B, which is there. Okay. All right. All right. I think we have one more. There we are. Okay. All right. So what system accepts an identity from a different organization? It's again Federated Identity Management. That's what Microsoft calls it. Which one uses UDP 389? All right, that's LDAP, Lightweight Directory Access Protocol. How long does a ticket granting ticket last? $10 is the normal lifetime. Then you have to re-authenticate. That's intended to be a working day. What's the European improvement of Kerberos? That's SESAME. All right. What access control model is used on a home laptop? Okay, that's discretionary access control, the least secure model. All right. So it's Robert and T and PC. Should really be going here. All right. And you know, I think maybe we should just stop because we've already gone a little further than we needed to, and my voice is given out. So maybe you just talk off early today. Yep. I'll stick around if people want to chat, but we'll do the next chapter next time, and I'm going to stop the recording.